In this video, we'll talk about the mathematics behind purchasing a home. This is an example of a situation in which you might encounter compound interest, and it does help to just go into these situations with a bit of an awareness of the terminology involved, of course, and then perhaps in studying the mathematics, that will help you understand what's going on in this situation as well. So when we talk about buying a home, most people don't pay cash for a home. If you did, then of course you wouldn't experience being charged any compound interest. But if you are going to go for a loan or a mortgage, then you would deal with compound interest. Mortgages are long-term loans where the lender has the right to seize the property purchased if the payments are not made. So mortgages don't necessarily have to only be for homes, but that is the most common item that is purchased with a mortgage. There's a little note in the textbook about the meaning behind the word mortgage. It comes from a combination of two old French words, mort meaning dead and gage meaning pledge. It is believed that the intent was that the debtor pledged the property to secure the loan, and if he or she failed to pay, the property was taken and was therefore dead to the debtor. When we talk about the terms for mortgages, how long they last, a common mortgage term is 30 years, but the term can range from 15 to 50 years. We have different types of mortgages. There are fixed rate mortgages, where the interest rate stays the same over the life of the loan. Adjustable rate mortgages would fluctuate depending on the economy. This could be a good deal if the rate's lower, but of course it's a bit of a risk if the rates do increase. And then graduated payments. That's another idea that's associated with mortgages. Sometimes mortgages can be set up so that you have a lower monthly payment to begin, and then over the life of the loan, the payment steadily increases. Okay, so that kind of connects to perhaps salary. So if you're expecting that you would get increases in salary over time, then perhaps you would go with a graduated payment situation. Could be interesting to compare with the other textbook we're using for class. If you think about Ron Blue and everything he's said and his financial principles, might be interesting to speculate about his thoughts on graduated payments, if that's a good scenario, situation for mortgages, or if he would suggest that you avoid those. We have different ways to calculate monthly payments. Our textbook section, this is chapter 8, section 5, they give you a couple different options. One of them is a table or a chart provided by the bank or whoever's issuing the mortgage. We're going to skip over that and go straight to a monthly payment formula. So here it is, and this should look fairly familiar, almost identical to one that we've just talked about. This is the same as the monthly student loan payment formula. The only difference you'll see here is that where the student loan one had a number in here for NT, the exponent in the denominator, here that's just left as two variables. So I think that's fairly small. I don't know if you'll be able to see that in the video, but check in section 8.5 in the textbook and you can find this formula. Alright, so here we're just expanding that student loan formula to different situations rather than just the 10 years to pay off a student loan. So we have still T is the number of years. And so for a mortgage, perhaps it could be 30 years, perhaps 15, something like that. All of the other variables still represent the same things, right? So we will take our knowledge of those things into the next example. All right, let's find a monthly mortgage payment. So we have a family, the Petty's family, plans to buy a home for $174,900. They've been offered a 30-year mortgage with a rate of 5.5% if they make a 20% down payment. What will their monthly payment be with this loan? Okay, so a couple things going into that monthly payment formula. We need to know the principal, right? And then of course we do need the rate, right? And then the N, the number of payments for each year, that's just going to be 12, so we are going with monthly mortgage payments, and so that would be 12 in every example. All right, now the other thing to notice in this problem, we are given two different rates. So I see this quite a bit. Sometimes students, I think maybe it's easy for your eye to just sort of glance at this quickly and pick up the first percentage you see. So you really want to make sure you be careful with those two percentages and what they represent. The 5.5%, that's the R for the mortgage. That's the mortgage rate. This 20%, that's the amount of the down payment. So we do need to calculate that, but we'll do that before we go into the monthly payment calculation. All right, so in order to find the principal, right, or sometimes we call that the amount of the mortgage, right, we would need to know the amount financed. And this is similar to a car loan, where the amount financed is the principal, I'm sorry, it's the cost of the item minus whatever the down payment is. All right, so here the principal would be that $174,900 minus the down payment. All right, well, what is the down payment? Okay, so I think you can do this calculation. 20% of $174,900, and that's $34,980. Okay, so then the principal would be the $174,900 minus that down payment. Okay, and then that's going to give us a principal of $139,920. Okay, so the next thing to do is to substitute everything into the monthly payment formula. So we would have the principal times the rate. Now this is the rate of the mortgage, 5.5%, over N, which is 12. This is a monthly mortgage payment. And then in the denominator we have 1 minus 1 plus R over N again. And then this is raised to the power of negative NT, so negative 12. And then what's T? So you would look through for the term for the mortgage. They've been offered a 30-year mortgage, so T is 30. All right, and then from there, at this point, I would suggest just entering this all in your calculator all at once to get the most accurate answer. A second option that's a bit less accurate, you could continue to calculate out maybe the numerator and maybe the denominator separately. And if you do that, just make sure you write everything down so that we can see how you rounded. All right, so I typed this in all in one shot, and you can really just go left to right, top to bottom, and then of course you just have the implied parentheses around the denominator. The other thing to notice too, because we have this negative in the exponent, make sure you do put parentheses around that exponent. Okay, so as you're typing along, when you get to there, it would be your exponent key, whatever that is, and then parentheses negative 12 times 30, right? And then you'd have finally another parentheses at the very end to indicate the end of the denominator. All right, so with those two parentheses in place, this should give you a monthly payment of $794.45. Right, and then if you're trying this on your own and you're rounding, just make sure that you're close to that. Like I would say within, I don't know, maybe within $10 or so. All right, another thing we might want to know is how much we'll pay in total interest on a mortgage. Right, so certainly it's going to be quite a bit. Remember that the longer you borrow money for, certainly the more interest you would be charged. So we're really looking at a 30-year loan here, so we should expect quite a bit of interest. Okay, so the interest is really just the amount that we've paid above and beyond what the home cost. Right, so if we're looking at the monthly payments, which were $794.45, right, if you multiply that times the number of monthly payments, which is 12 times 30, so one payment per month for 30 years, so that's 360 monthly payments, and then if you subtract the principal of the mortgage, that's going to give the interest. All right, so here's the reason why. These monthly payments, all they're doing is paying off the amount that was financed, this $139,920. Okay, that's the amount we couldn't pay for in cash. And then anything beyond that is going to be the interest. Right? So these monthly payments, remember that they're not paying off the down payment, so we wouldn't want to subtract or take away the down payment. So that's why we're not subtracting the original cost of the home. Right? So if you make this calculation, this turns out to be a very large number. This is $146,082. All right, so we've actually paid more in interest for this home than the amount that we actually took out the loan for. So one thing we might be interested to know is what are some of the things we could do to avoid paying quite so much interest. Right? So certainly you could go back to the scenario, and we could try to make changes to all of those factors that led to that amount of interest. So perhaps we change the cost of the home. Maybe we shop for a cheaper home. A 30-year mortgage. What if we go for a shorter mortgage? If we pay it off sooner, then we would perhaps have to pay less in interest for borrowing that money. We could shop for different rates, maybe a better rate, okay? Or we could try to put more money down and finance less on the mortgage. So those are some options. Let's consider one of those. Let's look at the difference in monthly payment and interest between a 15 and a 30-year mortgage. Right? So we're just going to go back to the monthly payment formula for R, and the only thing we want to change is the term of the loan. So we're going to keep the same principal, same rate, and we're just going to change time now to 15 instead of 30. Okay, so here it is, and then negative 12 times 15 as the exponent. So again, making that calculation and just adding parentheses around the denominator and around the exponent. That's going to give us now a monthly payment of about $1,143.26. Okay, so it's a bit more. It's actually $348.81 more. But notice that it's not actually double. So we're paying off the mortgage in half the time, yet the payment hasn't doubled. So that almost sounds like we would be saving some in interest. Right? So if we wanted to figure out how much we saved in interest, then we do the same sort of calculation. Let's find the sum of all of those monthly payments. So that's $1,143.26 times 12, one per month, and then times 15, since this is for 15 years. Right? And again, subtract the principal, and then whatever's left should be the amount in interest. So this time the interest works out to be $65,866.80. Okay, so that's a savings in interest. Let me label these things. So this is interest. Okay, this was monthly payment, and we've saved in interest over $80,000. Okay, so that's definitely a great option if this family were able to make that larger monthly payment each month. Then go for the shorter mortgage and save quite a bit here. All right, the interest is really of interest to us, pun intended. So in the next video we'll talk about making an amortization table, and the goal there will be to just see what portion of the monthly payment is going toward interest and what's going towards principal each month, and then we really just have a clear picture for how that's working out.